Good day guys, welcome to my YouTube channel. Make sure you subscribe to our channel. After subscribing to our channel, make sure you click on the notification bell. This will notify you anytime we drop new videos. In this video, I will give you detailed explanation on how you will be able to design your own multipurpose power bank at home. This power bank has 4 ports. The first 3 ports is for the DC output, and the fourth port is for the AC, that is the charging port. So these 3 DC ports, you can use it to power any DC load of your choice. Once it is 12 volts load, it will power it. Then we have a customized charger for our multipurpose power bank. Materials needed: 9 pieces of 3.7 volt 2200 milliamps lithium-ion battery, 12 volt 20 amps lithium battery with BMS already installed, 4 pieces of DC jack, digital display, DC bulb, and lamp holder for our bulb, male DC jack, plastic PVC casing for packaging. We will be drilling 3 holes first. The first 3 holes is for the DC output, the 12 volt DC output. Then after that, we'll be drilling another hole as shown in the video for the DC input, that is the charging part, where the charging port is. We are done drilling our holes. After drilling our holes, the next thing to do now is to insert our 3 female DC jack into the casing as shown in the video. Now, as you can see, the DC jack will be in parallel to each other. It means I'll be paralleling the first DC jack to the second and to the third. So the first thing I want to do now is to parallel the negative terminal of the DC jack. So I'll be paralleling all the negative of the 3 DC jacks together with each other. After that, I'll be doing that also to the positive terminal as you are seeing it in the video. So that is what I'm doing now. We are done installing our DC jack. The next thing to do now is to place our battery into the casing. This is our 20 amps 12 volts lithium battery with BMS. Then our 3.7 volts batteries also, we also check that also. We also put that into the casing to know if it will fit well. So that is what we are doing now. So I've already paralleled those batteries together, so it remains series-ing them together now. So I'm putting in the jack for charging. So that is what we are doing now. After this now, we'll be making our connections. We'll be seriesing all these batteries. So we'll be seriesing the 3 pieces of 3.7 volt battery. So this will give us 11.1 volts. That's the numerical voltage, that's nominal voltage. So that is what we are doing now. We'll be doing that first. Then after that, we will now be seriesing it with the bigger lithium battery, which is 12 volts 20 amps, that has BMS on it. While connecting your batteries, while seriesing your battery to each other, make sure your connection are correct. If your connection is not correct, it may lead to explosion. So please make sure your connections are correct. What we are doing here is to series our 3 pieces of 3.7 volts batteries together to give us 11.1 volts. So I'm also connecting the smaller batteries to the bigger battery that has BMS, as you see in the video. So I'm doing that now. After doing that now, then I'll need to rearrange it back into the box, the casing that I'm using. Then after that, I'll need to do other connections also. So I'll be connecting all the batteries together. So as I said earlier, they are series to each other to give us 11.1 volts. Our voltage is 11.79 volts. Then we will be testing the cell each. The first cell is giving us 3.88. The second cell is giving us 7.78. The third cell is giving us 11.68. This means our connection are very correct. After confirming that our voltage is accurate and correct, the next thing to do now is to start soldering the wires connected to the batteries. I will advise you to solder very well to avoid partial contact. Don't let partial contact happen when it comes to lithium batteries, because lithium batteries are very dangerous. So you make sure you solder well. After soldering, the next thing now is to cover up our wires. So what I'm doing now is I'm taping those wires with a PVC tape called Abo tape. So after taping, I will still add glue gun to it, so that there will not be partial contact and there will not be voltage leakage. The next thing to do now is to connect our female DC jack. So it already have positive and negative terminals. So what I will do now is this: I will first connect my negative terminal coming from the battery, then the negative terminal coming from the DC load. So I've connected them together. That's the first thing. So after that, I will be taping it so that there will not be contact, so that it will not cause explosion. The next thing to do now is to connect our positive terminal. So we are connecting the battery, the wire coming from the positive of the battery to the positive terminal, then from the positive terminal to the DC jack that is meant for the output load. So it's a DC multipurpose power bank. Don't plug AC load to it, it won't work. This is the cover. So I've drilled hole for the digital display. That's our DC meter. This will tell us the voltage on the battery. So that's it. Then the other hole is for the switch. The next thing to do now is to connect our switch to control our DC output jack. So that's what we'll be doing now. So I've connected the negative directly to the battery. So the positive now we'll be breaking it into two. So we'll be connecting it to the switch as shown in the video. So that's what we'll be doing now. So you'll be connecting one of that to it, then you will also be connecting the other to it. So we've connected our switch. So what we are doing now is to connect our digital display, this is digital display, to battery. So we want to be using the switch to control both the DC outputs and the digital display. So let's test what we've done. So it is intact. You can see it is working fine. So the switch is now controlling both the digital display and the DC output jack. I'll be connecting my DC male jack to this lamp holder. This lamp holder is a universal lamp holder, so it works for pin and threading. So as you can see, I'm checking the continuity of both the 2 points. So I want to know which one is positive and which one is negative. So I'm doing all this to be very conscious, so that I will not get anything burnt. So that's how I'm doing this. So I'm connecting my positive, that's my positive. So then the negative also. So I'm connecting both positive and negative together as shown in the video. So before you connect yours, make sure you use a multimeter to check, to confirm, so that you will not get the bulb damage. I'm done with the connection of my DC lamp holder to the male jack. So I'm putting my DC bulb. This is DC bulb. So I'm putting my DC bulb. So I'm using 2 lamp holders. So I have put my 2 DC bulb in it. So the next thing is to do the testing. So we are testing it now. So I will be switching on the multipurpose power bank. Okay, so we have 11.7 volts. So the next thing now is to connect our load. Okay, so you can see that's our load there. That's the first bulb. Okay, so you can see we are done with the construction of our multipurpose power bank. So the rating of this power bank is 25 amps, 12.4 volts. The DC port that is there can be also used to power a 150-watt inverter to power our AC load. So we are done designing our multipurpose power bank. Thank you.